Welcome everyone. In today's video, we are going to see what parallel and distributed computing is. So the reference of which I have taken from the textbook is Mastering Cloud Computing Foundations and Applications Programming by Rajkumar Boya. So this is one of the foundation concepts for learning about the cloud computing. So before moving on to cloud computing, we are going to first understand what parallel computing is. So parallel computing involves processing of multiple tasks simultaneously on multiple processors. A parallel program actually consists of multiple active processes that are also known as tasks that simultaneously solved to solve a particular program. A given task is divided into subtasks using divide and conquer technique, and each subtask is processed on different CPU. Now, what are the factors that affect parallel computing? Computational requirements are always and ever increasing requirements. So, if you take scientific or business computing areas, the requirement of computational requirements, that means you need more speed, you need more storage, everything is increasing. Now, the speed at which sequential CPUs can operate is reaching a saturation point. So, you cannot do everything using a single CPU that is operating sequentially. So hardware improvements in pipelining, superscalar systems, all these have already increased. And the development in networking technique is paving way for heterogeneous computing also. So as the internet connectivity and the speed, everything is increasing, heterogeneous computing is also on a rise. So all these are the factors that have led to the development of parallel computing. First one is the computational requirements are raised. The speed of CPUs that operate sequentially has already reached a saturation point. Hardware improvements in the pipelining and superscalar systems have also improved. And the development in networking technology has also led to the improvement in parallel computing. Now, what are the different hardware architectures for parallel processing? That means which of the hardware configurations you can actually perform these parallel processings. So we have actually four models. First one is single instruction, single data system. And it is actually not a multiprocessor system, it's simply a uniprocessor system. So moving on, the three ones are actually the multiprocessor systems, and of these some are more used and one or two are rarely used. So single instruction multiple data systems is the second one. So that is SIMD. Next one is MISD, multiple instruction single data systems. Then we have MIMD, multiple instruction multiple data systems. What SISD system stands for? An SISD system is a single instruction single data system, and it is capable of executing only single instructions which operates on a single data stream. That means you have a single data that has to be operated. You can take an example A plus A. So the operation is being performed on A, that is a variable A. Now most conventional computers are built using the SISD model. All the instructions and data to be processed have to be stored in the primary memory itself. And the rate of or the speed of processing element in SISD model is limited by the rate at which computer can actually transfer information internally. So its speed basically depends on the speed of the data transfer. Next comes SIMD model, that is single instruction multiple data. Here also single instruction is there but multiple data streams is present. So a multiple processor system, it's a machine actually capable of executing same instructions on all CPUs, but all of these CPUs will be operating on different data streams. So for an example, if you see here, Ci is equal to Ai into Bi. So here we have different data streams here, A, B and C. Now these are basically well suited for scientific computing, and they involve lots of vector and matrix operations. So this is the example which we have already seen, and they can be passed to all processing elements. That means we are having three variables here, three different A, B, C. So we can actually use three different CPUs. Okay. And the data elements of vectors A and B can be divided into multiple sets, and each processing element, that is PE, can process one data set. Alright. Next comes MISD. MISD stands for multiple instruction single data. So MISD computing system is a multiprocess machine capable of executing different instructions on different PEs, but all of them operate on the same data. Again here, multiple instructions are there, but they are operating on same data set. But the problem is they are not available commercially because data is always a high priority thing, right? So multiple instructions operating on single data are not in much use. So that is what I had already taught in the introduction slide itself. One of these machines are actually not much used, that is MISD. So you can see multiple implementation of SIMD for scientific computing, but for MISD commercial application is less. Next comes multiple instruction, multiple data. So this involves multiprocessor machines capable of executing multiple instructions on multiple data sets, and each PE, I am repeating this term constantly, PE stands for processing element, and each PE in MIMD model has separate instruction and data streams. Machines built using this model are well suited to any kind of application, and unlike SIMD and MIMD, PEs in MIMD work asynchronously. That means they can work, one is working before and another one is working later. Now, based on the way PEs are coupled to the memory, they are broadly classified into two types again. MIMD is further divided, that is into shared memory and distributed memory MIMD. Now, what is shared memory MIMD machines? In shared memory MIMD machines, all the PEs are actually connected to a single global memory, and they all have access to that common global memory. Such systems are also called tightly coupled multiprocessor system. One more important term you can see here is tightly coupled multiprocessor systems. The communication between PEs in this model takes place through the shared memory. Modification of the data stored in the global memory by one PE is visible to all other PEs. So through the shared memory model, actually the communication between the different PEs is actually taking place. Next comes the second category of MIMD machines, that is distributed memory MIMD machines. All PEs have local memory, right? That we are all aware of. So systems based on this model are known as distributed memory MIMD machines. They are also called as loosely coupled multiprocessor systems. The communication between PEs in this model takes place through interconnection network. Previously there was shared memory, now there is an interconnection network. The network connecting PEs can be configured to tree, mesh, cube, all these networks. Simple networking models, all these can be used for connecting the PEs. Each PE operates asynchronously, and if communication synchronization among tasks is necessary, they can do by exchanging messages between them. Now, another important topic of the day is approaches to parallel programming. So, how are the different ways in which you can actually implement parallel programming? So, either you can parallelize the data, or you can parallelize the process, or farmer and worker model. That is generally in computing terms we call it as master slave model, right? So these are the three different approaches to parallel programming. So we'll see one by one. So what is data parallelism? In case of data parallelism, divide and conquer technique is used to split data into multiple sets, and each data set is processed on different processing elements using same instruction. Alright, so the data set is split, the original data is split into multiple sets, and to different PEs this will be assigned. Now in case of process parallelism, what will be happening is a given operation has multiple activities, and each of the separate activity will be performed on multiple processors. Like if we have to perform matrix addition along with multiplication, so addition will be performed on one and multiplication will be performed on another. Farmer and worker model, one process is configured as master, that I have already taken the technical term for this farmer worker model, that is master slave model. So one process is configured as master and all other remaining PEs are designated as slaves. The master assigns the jobs to the slaves, and on completion they inform the master, which in turn collects the results. So these are the three approaches to parallel programming. Now we will be seeing another important concept, that is levels of parallelism. So which are the different levels at which this parallelism can be implemented? So there are actually four levels. First one is large, medium, fine, and very fine. So these are the four levels at which you can actually implement this parallelism, and all these three approaches can be implemented on either of these levels. So first level is large. So large means each process will be a separate and heavyweight process, and this parallelism is implemented by the programmer itself. Medium is an example, is like you create function or procedure, right? You in your program you are actually creating multiple functions or multiple processes. So that is an example of medium parallelism. Then comes fine. Fine parallelism is done by compiler, so it can be at loop or instruction level. And last one is very fine, that is only done by the at the instruction level, that is the basic level instruction. So instruction itself is parallelized, and that is done by processor, not by the programmer. So this was about our parallel processing, and in next session we are going to see about distributed computing. So basically in the parallel processing we need to see these basic approach, what are the different levels, then which are the different approaches, and which are the different types. And these are the very important topics, that is the hardware architecture for the parallel processing. So see you in the next class, and in that we will be discussing about the distributed computing. Thank you.